Hello, welcome back to ST589D, Fundamentals of Information Technology. I'm Rob Hepler. This is lecture 15. We're going to talk about enterprise computing. That's a big term for what's going on with information technologies and information systems today, which is that all the systems are interlinked. And all the systems serve every part of the company rather than have separate systems that serve separate departments. That's the basic premise behind enterprise computing. It's also what's taught in management schools these days, business schools. The whole concept now is that business as a whole needs to come up with ideas and manage projects and come up with innovation rather than different departments come up with innovation or creativity. So this enterprise computing is lockstep with what's going on in the management and business school. I, as you know, have an MBA and I teach business classes, so I'm very familiar with what's going on in the field. And I've had management roles in pretty big companies. So we're going to talk about that tonight. Talk about these things. We're going to talk about the information requirements. If you're going to do this sort of system for the whole enterprise, you have to design systems from the ground up to do that. Now, you're not going to design the whole enterprise system at once, but you have to be aware of what you're doing. So when you design part of it, it has to be able to work with the other parts. If you start from the ground and you say, we don't have an enterprise system, I'd like to have one, when you do new systems, you keep them open-ended enough and you consider what the needs are of the whole company as you design each system, and then you integrate them as you move along. Eventually, you have the whole system. We're going to talk about the functional units of enterprise. So we're going to talk a little bit about business and management tonight. I have talked about this before. To be a good information systems, information technology person, especially systems analysts, you have to have knowledge of business. The days of being a backroom person and just working on programs is pretty much over. Unless you're a programmer, of course, working for a company that produces software. But if you're working for a corporation, that's a luxury most people can't afford, is having a person that just does something in the back room. Unless you're a pretty big company like Ford or Chrysler or GM, something like that. Big companies do have people that do nothing but program. They're handed sheets and they do that. Most companies expect their technical people to have some knowledge of business or organizational process. So we're going to talk a little bit about that. Purposes, in other words, what do the departments do? So therefore, what do they need? We're going to talk about the technology, obviously. We're going to talk about e-commerce in this section because enterprise systems, of course, deal with e-commerce. We'll talk more about e-commerce when we talk about the internet and the World Wide Web, two different things, right? We'll talk about the hardware a little bit and the solutions. And backup as part of this lecture. It's kind of odd, but only because the backup is global in this case. We're just going to hit it one more time. Disaster recovery, of course, is part of backup and recovery. So we're going to talk about all of those things. Can't get my keyboard to work tonight, so I'm going to have to touch the screen here. So an enterprise, other than being a starship, aircraft carrier, and so forth, what is an enterprise? It's a large organization. Probably most of you don't belong to a very large organization, I'm guessing. But I don't know that, of course, but probably most of you don't. And here it says it's such as multinational universities, hospitals, those kinds of things. So it's a big organization involved in one goal and satisfying a lot of different constituents. There's a lot of external people that have a stake in big enterprises. And there's a lot of internal people as well. So that boundary normally, and that's where we use enterprise systems, the boundary between outside and inside is really blurred in these kinds of situations. The way we do business today, our partners, which could be the people supplying us, and our customers are often considered partners these days, should have some access to our systems. And that's kind of what we're talking about. Special computing, obviously, because of its size, but more than that, the concept we're talking about here. And of course, You have to have networking, and we're going to cover a lecture on networking down the road, not today. If that works, okay. So here's a little shot of information. That's what we're talking about, information technology, flowing around an enterprise. We're not going to go into this, but you can see all the different areas here. You've got locations. That's what this is implying. There's a headquarters, but there's also people all over the world, different locations. Notice the methods here: telephone, email, and so forth, internet, fax. Those have to be part of the process now. Cell phones. The security on cell phones, if you read the literature, technical literature, takes, and not just cell phones, but PDAs, personal data, systems, things you carry around with you, mobile equipment. The security on those things is a big part of the literature these days. So that has to somehow interface. And then you've got the functional areas. We'll talk a little bit about those. And here's another location. Same thing here. Printing, marketing, IT, engineering, and so forth. And notice they also list the customers. What they don't have on here is the vendors, the people that sell us the stuff, supplies, what we need. And also they don't list on here the people that deliver your equipment, your product, warehouses. Walmart is genius at warehouses and trucks and so forth. But it could be someone other than your company doing that. Retail stores. Campbell's Soup isn't ever going to deliver 1 can of soup to your house. They'd be out of business without retail stores. So that retail store needs to be a partner, which means, of course, you have to integrate them into your enterprise system in some way. So that's all very important to what we're talking about. So here's an enterprise, and you've all seen these kind of things, I'm sure. Traditionally, companies are organized in a hierarchical structure, and they often talk about span of control, which means how many people can you manage, essentially. How many people can you control, manage. And notice the CEO only has 3 people reporting to her. And they're usually chief officers, and of course this person reports to the board of directors. That's their job, to please the stockholders, and the board of directors are elected by the stockholders. And then the information kind of flows down this way. That's a traditional kind of thing. And down here again you see these functional areas we talked about in the last diagram. Well, traditionally information went that way. The CEO would make a big some kind of announcement is what I meant to say, and it would filter through down, eventually get to these people. There's actually another layer down here in a sense, and that's the people that do the work, some would say. But technology has changed a lot of this. As we know now, the CEO can send an email to everybody, bypass these people, and often do. These people can often email the CEO. And so our organizations are becoming what we call flatter. There's fewer levels than there used to be. But more than that, we're also sharing information. We actually see in Ford Motor Company, for instance, they're actually giving real-time updated information to the assembly line, letting them know what the plans are. How many cars do we need to sell to make so much money? What's the plan? What's the budget? And that's updated. As cars are sold, they get to see it. So the people on the assembly line now, the supervisors anyways, are shown this information in probably a limited format. And they're trained on what to do with that information. But they can see we have these many orders have come in since yesterday or since last hour, however often they update it. And so we have to do this. They can look at a plan and say, well, we have to make a different model down the road, so we're going to have to retool a little bit, so forth and so on. So the idea is we get the information to people that need it. We can allow them to do their job better. So we're actually shifting responsibility to everybody. And information technology has allowed us to do that. And that's what the enterprise system is about. and you're finding a flatter organization. And this allows us to use the diversity of our employees. It allows us to share ideas, be more creative. There's a lot of things it allows us to do, and it's inevitable. It isn't going to change. It's just going to continue to grow. Now, some people think, and these are usually the, quote, old school people, that this kind of process is destroying decision-making and management. Clearly, if your skills are these old hierarchical structures and you don't like technology very much, you have a problem with the new setup. But it's inevitable and it's changing, and it's what's allowing companies to innovate and do better. So it's happening. It isn't going to go away. Enterprise computing helps us address that. And this is the traditional view, but we can still think of it this way. The executives, of course, are the CEO, the VPs, those people. Middle management, well, those are the people that have to take, and I think there's another slide, but I'm going to write it up here. Normally, these folks come up with strategy, which is long-term. For instance, we don't have much market share in the small-size truck market, and we'd like to have that. So let's start a plan so by a year or 2 years from now, we can have a good entry in that market. That's probably too long anymore. But next year, we'd like to have an entry in the mid-size truck field. That's the strategy. Or the strategy might be, we need more market share in Germany. How do we get there? Those kinds of things. We need to cut costs, whatever it is. That's the strategy. These folks come up with the tactics, which is short term. What do we do this year to help us get there next year? If we have to increase our sales, then we need to increase production, which means if I'm in charge of supply, I need to increase supplies. But what supplies? They translate, if you will, the strategy to the tactics. Okay, the strategy is what we want to do. The tactics are how do we get there from here. And of course, they have to filter that down and translate it, communicate it to the supervisors or operational management. Those are the folks that make the day-to-day operations run. And this is pretty old school definitions, but it still applies to some extent. What you're finding is these people are more or less handing the information off. That's what's changing. And these folks are going their own way and making things happen, more so than they used to. And then, of course, these are the people doing the work. That's not quite true, but you understand what I'm saying. Those are the people that actually produce the stuff. And, of course, enterprise systems take information from here and move it up here and move it back and forth so people can manage. The production information is given to management. Sales information is given to management. Management thinking plans are given to the people down here now because of technology. But that's how the structure of management has traditionally gone. So the information the enterprise needs, it's gathered through the operations of the enterprise, obviously. So that means everything, as much, I shouldn't say everything, but as much as you can gets captured and stored. That's part of an enterprise system. For a grocery store or anybody that sells retail, one of the things you want to know is what goes through that cash register. Grocery store, they pretty much can do that themselves, or the retail outlet, Target, Walmart. But what Walmart has revolutionized, and as you know, I don't like Walmart much, but I think what they do with the technology is quite remarkable. They capture all that information, which everybody does, but then they'll also sell that information, or they pioneered this area, selling information back to the vendors. What time of day, who bought your product, what did they pay, all of those things. Did they buy it on discount? Did they not buy it? Did they bring it back? All that information is kind of given to the partners, which are the producers of those products. But of course, it's given not freely. They don't pay for it necessarily, but it's given in the idea that you're our partner. We're giving you this information so you can improve your product or cut costs, or so you have a better idea. We can't tell you how to make the product better, although they often do. But the idea, of course, is that we have information. Let's share it with whoever can use it to help us do better. And they have really tight contractual arrangements on how the information can be used and so forth and so on. They don't really know that it's me buying it. They know it's somebody my age, my income bracket, and so forth. It's very generic, and yet it's specific enough. And plus the history of all these transactions are kept by the enterprise. And it really can help. There was a tractor company that sales were going down and then they had no idea why. I'm sure I'm skipping a few details here, but they went back into their historic sales data in their service database, and they discovered that a growth in a certain area of the tractor, breakage in a certain area of the tractor and service calls had gone up, so they went back to the vendor that made that. They didn't make the whole tractor. Nobody makes all of anything anymore. And they suggested them, you need to improve this, and here's what we found out. Gave the information to them, they made a better part, which of course made a better tractor, and their sales went up. It's collected, combined, analyzed, that's what we're talking about. It allows management to make better decisions, of course. If you have trends, you can tell what goes on in the winter, summer, fall, what happens when it rains, those kinds of things, what are customers asking for. You can certainly make better decisions. Here's a chart talking about the four major activities of management. Planning is essentially strategy, tactics, where our goals, where do we want to be, and that of course has to be based on analysis. Before we had technology and before we had enterprise systems, each department, and even when we had computers, each department was doing this, but it was almost impossible to do it as a whole. You didn't have the data conglomerated. Each department had their own database. Now, people can look at all the data for all departments and make decisions in planning. Organizing, and we talked about how the structure is changing. Controlling, very important. What's the performance? Is the assembly line doing better or worse than it did yesterday? You can even look at that. There was a time, and I think it's gone now, but when we first started doing this kind of thing, there was information available. I don't remember how, but probably somebody that used to work there. GM had information showing that cars manufactured on Monday and Friday were inferior in quality than the cars made the rest of the week because, well, you can draw your own conclusions. A lot of people said it was because the workers on Monday aren't really ready to go, and on Friday they're distracted. So in fact, some dealers and the GM used that to their benefit and said, charge people more for cars finished on Tuesday, Wednesday, Thursday. Kind of silly because when you think about it, the parts are made on all days and they just assemble a lot of them, but there was a feeling of that and they used the information. So the performance can be important. Measuring the costs, measuring what's going on, the waste, measuring customer returns, repurchasing, all those things. And of course, doing something about it. And leading your employees, of course, is another major management process. And all the communications I've talked about have been impacted by the technology. We've talked about this before, an information system. As you can see, it's the hardware, software, it's the data. That's crucial. Data is considered an asset by companies now. When you sell a company, when you make the deal, one of the things you sell and measure as an asset, just like you do product inventory, is the database. Believe it or not, these days, that's considered something that has to be valued when somebody's buying the company. It goes along with goodwill, which is also something that's valued. People are part of systems. Don't forget that. We've talked about that before. The procedures are part of the system. Important. You can develop the best system, but if there's no procedures or the procedures are bad, it's not a good system. Okay, so you produce information. Of course, information is processed data, right? And you know what procedures are. So all of those things go into a system. And this goes against the grain of people that haven't been involved with technology much, that learn how to write programs in Flash or something, and they think they can just write the program and use it. Well, it doesn't work that way normally in reality, because the program may be great, but getting all the information or all the files you need to run that program may take a week, and you need the information the next day. You have a system that gives it the next day. It's not as slick, but if your people can't do it, if the procedures aren't there, it doesn't matter how good your program is. All right. Some of you probably know quite a bit about business and so forth. But let's talk about some of these areas. Accounting, keeping track. Finance is how you find the money or what you do with the money. Not the same thing. People often lump them, though. HR, human resources. That's who pays you. That's who figures out how much you should get paid. And you can see these functions. I'm not going to go into them. But the idea here, well, I'm going to talk about some of them. I changed my mind. This is the production side of things. These are the people that do the design for production, right? It used to be that they wouldn't work together, and engineering would design something and then hand it off to production, and they'd say, we can't do that. It'd take us 6 months to retool. It's great, but we can't afford it. We'd have to shut down the plant. And so you get the idea. Now, of course, they're on the same team, and there's this project team, and they work together. Marketing, they keep track of the market for you. Figure out how to access the market, what the market wants, anticipating, and of course, they come up with the ideas which these people then design. But of course, as I said, these people are involved in that process as well. So it's a team now. The marketing says, this is what we want to do. Engineering can say, that's a nice idea, but it's going to be very difficult to do that with our technology. So someone else may say, you know what, I know somebody that does that, but we'd have to do a partnership with them. We can get the technology, get this to marketplace tomorrow. Is that worth it? Well, the sales can help you figure that out if they have the data. We know how many people are buying the product now. We can have some idea with the help of the marketing department doing surveys and looking at the history of the sales. What do people want? How many of these people would buy more or pay more? Because the idea of innovation with products is that if you have an innovation no one else has, you can charge more for it. That's business. 2 ways you make more money: sell more or cut your costs. Marketing isn't necessarily going to help you cut costs. These folks are. These folks will help you cut costs. Engineering and manufacturing. Marketing is going to tell you what the market wants. So all these people have to work together. And customer service, those are the people that know what the customers are talking about. That seems obvious, but they know what complaints are coming in. They know what returns are coming in. They know what it's costing to repair things. Traditionally, when you placed an order with sales and you wanted to find out what was going on with that order, you'd call customer service. And they would call sales and say, where's the order? And they'd say, I don't know. Manufacturing has it. So you'd have to call manufacturing, and they'd say, I don't know. I'm not sure what we're producing today. You get the idea. So enterprise system, you call customer service, they pull up what's going on. They pull up the information in the order, and it says it's here. And it also will tell you, because the processes on the plant are also automated and the information is available online. Customer service calls up and says, okay, your product's in the assembly line. It's going to be ready tomorrow, which means we'll get the distribution. Folks have already put an estimate when they can get it there. So boom, one phone call and they can tell you everything that's going on. That's how enterprise changes. And of course, here's the folks that make it happen, IT. information technology. All right. Here's the functions. And of course, excuse me, of course, these are the things you have to automate and make work. These are the functions you need to have in your system. And this is just accounting and finance. Budgeting, that's of course figuring out from the strategies, what money do I need to develop those strategies next year. Budget is where you start all your planning. You're given so much money. Of course, budgeting starts actually with this, forecasting what you need. Once the forecast is in place, upper management tells you whether you can actually get that budget, and if you can't, you got to pare it back. But at some point, you actually produce a budget. And then what you can do as the time goes on, the enterprise system can tell you whether you're on budget, over budget, under budget. And then you can figure out why by looking at the forecast, look at the history, and so forth. Billing, obvious, that's where the money comes in. Well, that's where you tell folks what they owe. Payable is where the money goes out. Who do we owe what? AR. Financial systems, cash management is what do you do with the money you get? How do you invest it? Do you put it back in the company? Is it worth it? Do you develop new products? Do you invest it in bonds? Do you buy another company? That's kind of cash management. Or do you borrow money when you need it, or do you sell off a unit? You lay people off. How do you handle cash? Investment, that's related, of course. Financial reporting. The interesting thing about that, although it's true of all of them, but especially in this one, if you're a publicly owned company, your stock's traded on the stock market, you have a lot of external parties. You see, by federal law, if you're a publicly traded company, there are certain statistics, reports you have to publish publicly, and you have to send it to all of your stockholders and make available to people that might invest. Defined by the feds, and you better comply with that, or you're in violation of the law, and you can be shut down. And so that's some of the things you need to consider. Sales, of course, that comes from outside somehow, pulled into the accounting system, which of course is going to go in here, maybe. Payables come in here and go to here probably. Receivables, well, that's going to have something to do with billing. And then somebody's billed and then their money comes in. You get the idea. Cost accounting deals with being able to know what your cost of business is. And one of the things you need to think about there is they're actually doing cost accounting, which means, as they mentioned here, which means they're actually breaking production, manufacturing down, and they know how much it costs for each little step in the production process. And the idea there, of course, is if you can improve on that one little step somehow, you're going to improve the whole cost structure. And you can also assign responsibility for each part of it. HR. Of course, HR also has a lot of external parties, like the government, like unions sometimes, cities, a lot of external, just public relations people, activist groups. There's a lot of external things they have to think about with HR. For instance, I'm not sure this might have changed, but used to be if a U.S. company or any company did business in Germany, the HR files, and that means the actual zeros and ones, the computer files as well as the hard files had to be stored in Germany. So you couldn't transmit the information back to Cleveland. You were headquartered in Cleveland and keep the information there. It had to stay in Germany, just one of their laws. So that's something to think about. And of course, who you hire, what characteristics you need and so forth comes from all the departments. All right, those are just a couple of the examples of systems to think, functions to think about. We're not going to go through all of them. Computer-aided design is an enterprise system because what it does is it breaks down a design process into as many steps as you need to, and it's accessible by everyone in the company. For instance, take an airplane, for instance. Airplane has a lot of parts. It also has a lot of screws. It has a lot of fabric. It has a lot of joints. So what you can do to an airplane, you have a picture on your computer of the airplane, you can double click on the wheel, for instance, the wheel assembly. It'll break that apart. And a different team can design parts of that wheel, and different teams can make modifications to the, quote, online blueprints, which the computer-aided design software keeps track of. So, and then if someone else goes in and looks at it, that change is reflected there. If we think about the cost accounting, let's say somebody figures out a cheaper way to make wheel assemblies, you can have that reflected instantly. Let me give you a better example. That example was difficult for me. Think about an automobile manufacturer like General Motors. They use parts across different product lines. So they may be able to make a chassis that'll work on 3 or 4 different models of cars. They have different bodies, but the chassis might be the same. So what you can do with a computer-aided design system is the chassis is part of each of the different, like Lincoln and Mercury and Fords. They may have the same automobile chassis, but when you click on the Lincoln, it has other different parts. But a lot of the parts are the same. So if you're designing an axle, it might work on 5 models. If you change the design of that axle, it changes it on the computer in all the models. So if you design a cheaper way to make an axle, every one of those, the cost of every one of those models goes down instantly on the computer. And you can also test things. These systems allow you to test parts before you produce them. The software will simulate, emulate what happens if I change this product to look this way or to work this way. So the idea is all kinds of people are working on that same car in many cars, but changing it in one place changes it in lots of places, and the benefits are seen or the problems are seen in a lot of places. And engineering, same idea. Manufacturing, well, that's just allowing the computers to control the assembly line. Of course, these robots here, that's what these are, assembling cars. The beauty of this, when we move to this process from the old process, now we can actually shut down the assembly line, or maybe not for more than a minute or two, and start producing a different car, different model. It has to be similar, of course, but you can reprogram the robots then, with computer-aided manufacturing, to switch to a different model, different movements, different bolts, different actions, without shutting down the plant, moving everything around. That's the advantage of this kind of thing. Also, you can monitor what's going on closer than if people were doing it. You can also, of course, forecast more closely, how long it's going to take to do something. Machines usually don't take lunch breaks, don't need a day off. You get the idea. Manufacturing allows you to keep track of everything that's going on there. And if the machine's having difficulty and has to keep retrying something, something could change, but at least you know about it. And integrated manufacturing, similar, just integrates all the whole manufacturing process in others. MRP is a huge part of enterprise systems. What it allows you to do is integrate your whole logistical system. That includes, as a business, what happens from your vendor, so the people mining the products you need, how that gets into your production line, how all the materials you need to do production are managed, how the finished products are managed, and all the inventory that's not finished, how it's managed from the back door of your plant to wherever the customer is. It's integrated to such an extent that if you redesign something, the system notifies everybody down the line, including the vendor, who is not part of your company normally, but they're a partner now with the way we do things now. So any little change you make is reflected throughout the whole system, including the ordering process, including the pricing. Everything is kind of automated. There's a lot more to it. I'm simplifying here. but I just wanted to get the idea that any materials needed in the whole process, from the supply, production, delivery, sale, is managed as a whole. So any change anywhere, if the vendor out here tells you, you know what, the shipment of whatever the product you're using from the ground is going to be delayed, that's going to impact everything down the line, including customer deliveries. Well, the system MRP is going to tell you that, and you're going to be able to make choices about that. Okay, he's our major vendor, but I have an alternate here in Ghana. I can call them, and they can get it here quicker. It's going to cost us a little more, and you can kind of put that into the system, and you get the idea. It allows you to make decisions. That's an MRP system. Also includes inventory. So MIS, Marketing Information System. I can, it's the same idea here, of course. I can give you some first-hand examples from when I worked for the first supermarket. Our vendors, the suppliers, which would include Campbell's Soup, distributors, would say, we can sell you a bunch of stuff at a very, a whole truck, or, truckloads in our case. We had $1 billion in sale, pretty big company. They would give us a discount for certain items if we could be sure they got to people who didn't use their product very often. Number one, so the discounts should only be given to certain people. Number two, they wanted to know what happened to those people 6 months down the road. We could do that with our frequent shopper card because we could track people that normally didn't buy certain Breyers ice cream. They always bought Creamland. Well, what if we put a discount on Breyers and brought the price down to Creamland only for people that bought certain products before? And you could do that in a couple of ways. We used to do it by the card itself. Only certain people got the discount at the cash register. But only people that have the card maybe got the discount. But you could also specify by mail by sending coupons to people, or we actually didn't have to send coupons. We sent them a letter saying, when you buy this, you're going to get a discount at the cash register because you've never bought Breyers before. So please buy Breyers now. And then we could track those people. The marketing information system would do that. We would take out the data from before we sent out the information, the discounts. What were their sales? This segment of people. Then we would give them the discount now, and we would track their behavior for 6 months afterwards. And then we would know whether it had an impact. In other words, if people used the discount to buy Breyers once, why would Breyers give them the discount again? That kind of thing. Did the discount work? Did people get more loyal to Breyers than they used to be? Now that only works, of course, if we have information from the cash register, if the marketing system can communicate with the cash register, and so forth and so on. Enterprise system takes care of a lot of that. Also marketing research. Who needs what, surveys, those kinds of things. This is a growing area, has been for a long time. Salesforce automation, it's growing now in that a lot of these applications are available on mobile devices, cell phones, PDAs, and those kinds of things. And we developed one years ago, but of course you actually had to use a dial-up, but salespeople had them. There was little cups on the dial-up, and you could put the phone in there. So you would actually use them at the client site and dial up, get the information, and what it would show you was what the customer bought last time or historically, and what the forecast should be for them today when you go make that sales call, for instance. They should buy this much based on past history. So it would give you some idea before you went in there what you'd done with them, or if it wasn't you, the last salesperson, and you could negotiate better. And you could come up with a better price or know what they needed. So you were knowledgeable. So you became a partner. That's what sales is about, of course. Convincing people you know what they need and then giving it to them. So these systems allow you to do that. And even more than that, you can even do things in there like put their wife's birthday, their kids' ages and birthdays, and those kinds of things. And a lot of people do that with these systems. They can call up on their cell phone when they're making a sales call. All the information they've gathered, and when they gather more information by talking to the receptionist or something, they key that into the system for next time. And that goes into the database, and other people that call them can pull up that database. And you might be thinking, wow, that's a violation of privacy. Well, I don't know, could be, but it's sales. It used to be people kept that information up here, and that's what made a good salesman. Now, of course, it's delivery of the information. Everybody has the information. It's how you make it look like it's spontaneous and not something you read off your cell phone before you walked in the door. Part of sales. It's what enterprise systems allow you to do. And of course, you can see some bad for the customer. Perhaps other parts of the business could use that to locate you. Or maybe, this is sales. Maybe the marketing department could use some of that information to send you discounts on your birthday or something. So that's another system that's integral part. The distribution system is how you get your product to the marketplace. So it's after the manufacturing process and before the sales location, like retail, like between the door and Kmart, Target, Penny's. And it allows you to forecast. Now, one of the things when you study business is we've changed our viewpoint on inventory. Inventory used to be considered an asset. In other words, when you value your company day-to-day basis, you would total up all your inventory and say, wow, we're worth a lot. We have a lot of inventory. No, we don't do that anymore. Inventory is now a cost. At least that's the way we think of it. In a sense, it's still an asset, but we think of it as a cost because if money is tied up in parts, unfinished inventory, stuff in trucks, that's money we could use other ways. So an enterprise system allows us to be very efficient. We try to pare down our inventory as small as we can so there's less money tied up in it. And we use that money to invest in innovation, retooling our plant, training our people. That's the idea. So enterprise systems allows you to keep that inventory small because we had an integration with the ordering system, with our vendor, with the retail store, with the customer. We can do that because we can manage the whole process. We used to keep a lot of inventory because we couldn't manage that process. So we made sure we had a warehouse full of stuff so if we never ran out in the store. Don't need to do that. It's so efficient now we can cut it very thin. Other costs associated with inventory besides the dollars are the dollars, for instance, you have to insure inventory. You have to pay storage. You have to have utilities for a warehouse. Another one you might not have thought of is if you have a huge warehouse full of things that have parts, and your vendor sends a message saying, hey, we just figured out a better way to do that part. From now on, everything you make is going to be 100% improved and you'll be able to charge more for it. Well, great. We got a warehouse full of the old stuff. How do you sell that when somebody else has a better product on the market? So if you keep that to a minimum, enterprise systems allow you to do that. If they come up with a new product, you only got a few out there to get rid of, or even just trash them and start with the new ones because you can charge more for them. But if you have 10 million of them, you got to sell them somehow, which of course explains how things get into the dollar store. Because they made too many of them, and now there's an innovation. That's one reason. There's other reasons, but we're not going to talk about those. So inventory management is very important. And of course, tracking, shipment. I think we've talked about that. Walmart knows where everything is on every truck, and they know where every truck is. They're in communications with the truck, and they can actually change the delivery point of the truck while the truck's on the road and say, you know what, we need that stuff in that truck more in Phoenix than we do in Denver right now. Change your route. And they do that kind of thing. So their inventory, if they pull it up on a computer, is everything from warehouses, manufacturing, supplies, trucks. And they have a really good picture of that. I know there's a lot of business, not much technology, but I think it gives you some background. That's the idea here, is to give you some reason for some of these systems that you might hear about or how people are doing business these days. Customer interaction management. This is similar to a sales system because sales systems, sales contact, sales call systems keep track of this as well. But this is a little different thing. This is not sales agent initiated. This is customer initiated generally. Or if you're doing telemarketing, it keeps track of this kind of things. I think I told you, did sales calls for MCI, long distance between jobs once. Probably the worst job I've ever had, but they had a computer system that was incredible. You just sit there at a computer and the phone numbers would come up with names and addresses and call automatically. By the way, a little tip, if you answer the phone and nobody answers, they're on one of those computer systems because you answer and then it connects you with somebody on a phone. That's why there's no sound. So just hang up if you get one of those. But so you'd be able to track everything that's happened with that person, even instant messaging now, if you're doing that kind of thing. Some customers you might be. Chat, anyways, online. I do that often for support on the software here at Tech. But the system can keep track of all that for you so that you can see what happens. It can prevent liability issues where the customer says, no, you told me to do this. Well, you can pull up the transcript. But it also allows you to know when's the last time we talked to them. Maybe we got to call them back, follow-up calls. There's a lot of things you can do in terms of customer service there. This is a growing area as well. You know, at the IT department, the people that do all this, we've talked enough about that. In case I haven't mentioned it, the CIO is the Chief Information Officer. And that's growing in importance as a few years ago, I don't think it's true anymore, but the guy running Ford used to be the CIO of the European division. He got promoted to CEO because they thought they needed somebody in that role, the new information technology. Office, OIS, you don't hear much talk about this, but it's the same idea, and this is kind of like the low-end operational end of an enterprise system. It includes stuff like Microsoft Office, Excel, all the things we've talked about in here, but also some of these others, like the customer contact system might be important for the customer service department, for the sales department, anything, but there's interfaces. This is the stuff, though, that allows the day-to-day operations to go on. How do we get an invoice printed out, or if we need it printed? Or how do I need to get the information to somebody that's making a decision? How do I research a customer complaint? It used to be called Office Automation. Now it's called Office Information System. Same thing. Spreadsheets, Excel, interfaces with all the other enterprise systems. Just a term. I don't know if anybody believes this guy is at work and thinking about TPS. I don't know. I think he's a good-looking, well-dressed guy, but I don't believe it goes with this slide, but that's okay. Transaction Processing System, TPS. This is details. This is every transaction that hits the company from anywhere. TPS, Transaction Processing System. So what that is everything that goes through the cash register at the grocery store, everything that goes through a cash register at Target, all those things. If you get those transactions, of course, what can you do? You can find out that you're out of inventory at a store without being at the store, for instance. You can find out how much money is coming to the bank that night, how much of it is credit cards, how much of it is cash. You can then take that information and do something else with it. The TPS is really about getting all that information into a database. It actually isn't intended to do analysis. It's kind of like capturing it all. Then we do other things with that, like create a summary database or reports that allow people to use that data. TPS is kind of like the raw stuff, but it actually is every transaction you get. MIS, this is the information system that allows you to do the decision making. Nothing big here. You can see this is at a university, and there's different kinds of reports. It's the detailed report, summary report, exception report. Those are some of the things you see, and this, of course, is a graphic version. But you'll see those kind of things. Another thing you'll hear talked about sometimes is a dashboard. And a dashboard is a piece of software that allows management to get a summary, one screen, one-page summary of what's going on, a heartbeat, if you will. And the dashboard is generally updated, usually not in real time, but in near real time. Maybe every 20 minutes you get all the transactions through the TPS summarized and pushed up to a dashboard, so upper management can have that running on their desk, and from every 20 minutes see how sales are going. They can click on something and drill down and say, why is this sales down? Well, it's because there was a hurricane in Miami. 10% of our sales come from Miami. Oh, okay. What are we going to do about that? But they can just notice the dashboard probably would turn yellow if the sales went down a certain amount, and you can define that. So it's visual, and then you can drill down and find out what the details are from the TPS. So it's like the dashboard in your car in a sense. It's giving you information in summary form on the operations moment to moment of the company. Works very well. A lot of work behind the scenes to get all that to work, with first getting all those transactions and summarizing them in a way that can be used by the dashboard. And then, of course, when they click on the dashboard, kind of unwinding that information, going back to the original again. It's quite a process, but it's what's going on today in management. A DSS allows you to make decisions. There's an example down here. Executive information system is kind of the same thing. It's just a little more strategic, a little higher level. But the idea here is you can simulate the business based on the real data. So you're constantly getting real data. And you can say, well, what would happen if the price of oil went up 10% the next 6 months at 2% a month, or next 5 months, I guess, at 2% a month to our sales? And you have all the rules built in there to dependency on oil for your product. And you can actually, it'll forecast for you. Or what if I signed this new union contract and had to pay my workers X amount more money? What's that going to do to my profit? Those kinds of things, you can actually simulate those and get results almost instantly. And it helps you analyze things and helps you make decisions. They don't make decisions, the software. They just help people make the decisions. So as you can imagine, behind the scenes here, as a technical person, building these systems can become very difficult because you have to define all those rules. What is the relationship between petroleum and your product? That's not clear in many cases. What about soap? What's the relationship? Well, there's something there because you have to move the soap. That costs you energy. That costs you some kind of petroleum. Hopefully the soap doesn't have a lot of petroleum in it per se, but probably the wrapping does. The plastic, whatever it is you put it in. The processing, the plant, the trucks that move this, you get the idea. There's something there. So all those rules, the labor costs, all those little things are put into this system, and it's constantly tweaked. And a lot of the stuff that goes into the rules is created from existing databases. You run an analysis and say, well, this is the past relationship between oil and our costs. So you kind of put that in as a start, and the executive can tweak that, take a look at what you've put in there as a programmer, as an analyst, and they can tweak that. Say, yeah, I think that's probably right historically, but I think it's going to be this way in the future. Boom, what happens? How do we handle that now? Where do we reduce costs so we don't go out of business? Those kinds of things. Very important part of enterprise systems. But all the other systems we talked about, this is the culmination. All those other functions feed in here in one shape or another. If your accounts receivable is not getting as much money in, of course, that's what's happened to mortgage companies and banks, right? They thought they were going to get this much revenue. They ended up getting this much revenue. That's a problem. But so that's the receivables part. Maybe your marketing, maybe your cash is going down because the marketing isn't doing well. Maybe someone else came up with an innovation. All those things can be thrown in here, but those are coming from different departments, can help you. Maybe your product's breaking more often. Well, the engineering, customer service can feed into it. Everything goes into these systems that we've talked about. Well, an expert system is different from a decision support system. It actually tries to put the rules experts use to come up with decisions into the computer. One of my jobs at the supermarket was to create a pricing system, for one thing, based on purchases from vendors. and also to have a vendor purchasing system. So when the vendor came in and made a call at our corporate office, our vendor manager, the purchasing agent, they call him, or purchasing department, could pull up everything. I mentioned earlier on mobile devices. Well, they could do that at their desk when they came to call on them. They could also look at what was available out there in the market from other vendors, or what bids they'd had from other vendors. Some of them they got electronically through our website, some of them through emails that they keyed in, some through phone calls. So when that person came in to sell them Campbell's soup, and it isn't just Campbell's you get it from, it's distributors. Fleming was one, I think it's been out of business now, but they were one of the biggest. You could kind of use those against whoever was sitting in front of you. This person gave me a better, you might not mention names, but I got a better bid here, can you beat that? It sounds silly, and they used to do this, of course, in their mind. When we first started automating this, I'd go interview them, and they'd say, I don't know what I do. I don't know what the rules are. I do it with my gut. That's what this is about. It's instinct. We can't define this. So over a very long, lengthy process, eventually you figure out there actually are rules on this kind of thing, and they would, of course, do that. We also did a similar thing in the way products are displayed in a grocery store is very important. The products on the bottom don't sell as well. You probably know that, but maybe you hadn't thought about it. So how you put things on the shelves has a lot to do with how much money you make. And so we developed we use third-party software, we purchase software, and then we put all our data into it from the enterprise system. And then it would make recommendations. You need to move this over here, this up here, based on your database and sales, and based on the information we got from other places. That's an expert system. Probably one of the best examples, though, of an expert system is diagnosing diseases. It's often used kind of as a way to triage. In other words, eliminate the obvious, especially for places where there may not be a doctor, those kinds of things. But what you can do is put all the medical tests the doctor runs and have the expert system give some suggestions. It's supposed to not make the decision, just help the doctor make the decision. But a great example of how it might be better, it might not be true anymore, but it used to be that if somebody from New York came to New Mexico, got bit by a flea, caught bubonic plague, and went back to New York, they usually died because they couldn't diagnose it. Who would think you had bubonic plague, for gosh sake? That hasn't been around since the Dark Ages. You know, and those doctors in New York don't think of that. That's not something that's going to pop into their head. Oh yeah, you have plague, Black Death. However, if a doctor in New Mexico diagnosed that, they might say, oh gosh, we better get some antibiotics in them, and probably you'd be saved unless you were ill or something. Well, an expert system doesn't have that bias. Based on the symptoms you feed it, and the symptoms are not just typed in, they're also blood tests that go in automatically, and temperature and so forth, weight gain, or all kinds of things go in automatically. And it will actually list that. And the doctor in New York would go, Black Death? Plague? I hadn't thought of that, but that's exactly what it is. It might be a bit of an exaggeration, but you get the idea there. This runs off a base of facts, which continues to grow as you develop the system and improve on it. Somebody has to constantly monitor it. You don't just build the system and walk away. You build it and keep developing, and the software does it itself. There's an old computer term, heuristic, which means the program learns. In other words, if it comes up with a bad diagnosis, it may ask the doctor, you know, if you have time or someone else does it, you tell them this was the real disease. And the computer might come back and say, what could I have asked to make that a correct diagnosis? And you give it to them. It goes into the knowledge base. The next time it's going to ask for those tests so it can come up with a more accurate diagnosis. The inference rules, that's actually, believe it or not, a generic bit of programming. I think I mentioned the other day in Lisp, or ALGOL. These are called artificial intelligence languages. And what they allow the software to do, what Lisp does, is takes these facts and finds patterns. And then you can develop questions based on the patterns and so forth. So it starts at a solution, works its way back through the facts to come up with the questions. automatically. As you add facts, it creates questions. Think about it that way. It's quite impressive technology, and I know we've given some obvious examples, but it's also used in analyzing minerals, analyzing geological fields, looking for oil, analyzing. There's a lot of things it's used for. The advantages are several if you can get it to work. If somebody has all the information in their head and they die or retire, you're in trouble. If you can get at least 80% of that information automated, if they retire, you've got a lot of it already there. You can also access these systems from anywhere. You don't have to have somebody travel out there to do the diagnosis or the analysis. You can do a lot of it via the software. So those are some of the advantages. The disadvantage, of course, though, you've got to constantly update them or they become obsolete. I guess that's true of people as well, isn't it? And here's an example of how you might do that. And this expert system is, you see this on a lot of websites. There was a story a friend of mine told about, he was taking care of his mother, taking her to the doctor on a regular basis and telling the doctor the symptoms and taking care of it. Well, the sister came to visit and saw those symptoms and Googled it and found out that those symptoms meant she was diabetic and freaked out and said the doctor's a quack because he doesn't know what he's doing, you know. Well, that's not what we're talking about. That's not an expert system. That's Google. And this is a web-based application here, and they're just trying to get you through, in this case, problems with your printers. An expert system is used there. Why? It's so the company spends less money on service, of course. If their software can help you solve your problem, they didn't have to have a person on the other end of the line in India. So expert systems can be used in a lot of ways. We talked about ERP. No, that was MRP, I'm sorry. Enterprise Resource Planning. Similar to what I talked about with materials, except now we're actually talking about not just the materials that go into the whole process. We're talking about people and machines, everything now. And how does change in one thing affect others? If I reduce my staff by 5%, what's that do to production? If I don't reduce the production people but reduce the distribution people, do I have to cut production because I can't deliver? You know, all those kinds of things, the relationships. It allows you then to bring everything together. You can see the billing, collections, distribution, and so forth. So now we're actually talking about the whole system, and that's an ERP, Enterprise Resource Planning System. Used a lot. Every company uses those now. Big companies. So you don't get a lot of gut people saying I do it with my gut anymore. Good managers now use the system and then use their gut, I guess I would say. Customer relationship management, we've talked a lot about that in there because of my experience. That's the frequent shopper card, which isn't used as much now at grocery stores like it was when we used it at Furs. It's pretty generic now, but they can track your basket and what you've ordered and what that card has ordered and track trends. It works in a similar fashion as I've talked about. Other places like Amazon use CRM really well, if you've ever used Amazon. They keep track of even the things you searched on, the things you've clicked on, the things you've actually purchased, the things that you had on your wish list, the things you had in other lists, things you deleted from your wish list. And what they do then is take all that information, one of the things they do, and compare it to other people's all that information. They compare the two of you. And if your lists have an overlap or at least a similarity of a certain percentage, they'll say, other people that have your pile of stuff, your pile of information, bought this. Maybe you want to do that. So they're trying to match up things, and that's customer relationships management too. It isn't just frequent shopper. Those kinds of things. It's also that sort of thing, and it's huge online. Everybody uses it online now, whether you know it or not. Content management system, that's what we had at Kinko's, of course. The idea was that we could, our customers used us as content management. And what you can do is have all your documents in one system, and then it gets downloaded to wherever you need it to go. So what you do is define this stuff, and then the people that have the information just pump it in here with a parameter that says this is where it needs to go, and then other people can access it. So the idea is you just manage the one database. For instance, if you're printing flyers for a new car, for an existing car, pamphlets you're going to send out, or a web page or something, a lot of the stuff you can use from past ones without people knowing it. So you have a database of images, a database of text that you can pick and choose and create another flyer for a different purpose, but you don't have to reinvent the wheel. Another advantage is the information doesn't have to be stored in all of these places. It's just stored here. The difference here is, of course, this is visual. It's not all visual, but the idea it's multimedia. Let's put it that way. It includes video, sound, documents, scanned-in documents, wills, contracts, whatever. Advertising, photos. You may take photos of all your stores and store it here so people can retrieve it as they need it. The idea is all that stuff doesn't have to be stored at these places. One place and managed so it's not obsolete or duplicated, and you can update it. When you print it, you get all the images from here and print it, and the printer doesn't have to know where or how they got it and so forth. It's a growing field. It's huge. We made a lot of money at Kinko's off that. I think people are doing a lot of it themselves now. You should know what a portal is. You're taking these classes. We have something called a classroom portal. It isn't really a portal, but we call it that because it's a portal to the classrooms. A portal is usually more general than that. And it usually is based on web things, but that's okay. In our case, it gets you to the information you need for the classroom. Okay? A portal is a gate, a portal, a door, like a port on a ship. It's a way to get somewhere. On the web, something like Yahoo is a portal. MSN is a portal. It's a way to open a door to the internet. So you go to one site, and it has all the links to everything you need. Corporations, enterprises will have in-house portals. So you go to this one website, and from there you can find HR, training, payroll, whatever you need to find out is in that one site. That's a portal. I think I've talked a lot about this, maybe not with these terms, but the data warehouse is where all that information is stored. History to right up to when the last time you talked to the cash register or customers, whatever it is. And of course, from that one single warehouse, ERP, MRP, CRM, you get the idea. The warehouse is the heart of the whole thing. So that's why database technology is so important these days, why a company like Oracle, is a database company, is so huge. It's addressing this information. And what Oracle is doing now, they sell this software. That's how they started database. But now they'll sell you an ERP system which works on Oracle database. So now that you have our database, buy our software. They've branched out their company because it made sense. They write software that's very efficient with their database, and they have experience. So you get one solution, one vendor, one service, one support. And a lot of people are doing that these days. IBM sells these systems too now, services. But it's all based on the data warehouse. An extranet. We'll talk more about extranets and intranets. That's an N, sorry. Intranets, when we talk about the web. Next time we'll talk about communication networks, and then we'll talk about the web after that. An extranet is essentially a portal or an access point into your internal data, okay? So what you can do is have your internal systems be very secure, and only the people internally can access it, But of course, as we talked about, you might want your vendor or your supplier to access some of your information, or your customer to access some, or production to talk to the supplier. So these are like holes you punch through the firewalls, through the security to allow people to see a window of your data. That's an extranet. It's external, but it accesses internal systems. So it's called an extranet. An intranet, as we'll find out later, is when you use internet technology, but there's a wall around it. Only people inside your company can use it, but you're using the same technology you used before. A web service allows people to access software, if you will, or processing services via the web. That's what it says. And you can look at this. What you have here is, of course, one inventory, and somebody requests information. It goes from the database, and the web page talks to the database, not the customer directly, and you get the information passed on. I mean, the idea here is, with a web service, is you have someone else develop the service, make it available to you via the web, so you don't have to have it in-house, which means they're responsible. And it could be somebody within your company, but it means all the people using it don't have to be responsible for backups, recovery, development, enhancements, fixes. That happens somewhere else, whether it's an outside company or your company. They mention here business to business, B2B. That's, of course, as opposed to customer to business, which is what you do when you're on Amazon. That's you as a customer, Amazon a business. Business to business is when businesses communicate this way. And we'll talk about that again when we talk about the internet. Workflow. This allows you to keep track of things and break down processes in your company, and the idea behind any improvement system that's come up the years, process improvement things. Sigma 6 is the big one now, is you need to have a workflow so you can break the processes. And if you can develop in the software what your workflow is, you can manage your workflow. That's kind of the idea. But I'm not going to go into that much in any more detail. VPN, of course, is a network you design that's private. You can have other people design them and make them, but they're your networks. It's called a VPN, Virtual Private Network. It's called virtual because it's a mix of things, different ways to do things. And that's about all I'm going to say about this. We'll talk a little bit more about that when we talk about networks. You should know what e-retail is. Electronic retail, that's what the E is used for. The retailers sell their products on the web. I've never heard it called e-tail. And the idea, of course, is everything's done electronically, including the transfer of money and the verification that you have money. That's e-commerce. It's all done electronically. We've all done online banking. You've heard about online trading. I don't have enough money to do online trading. Some of you do, and I'm sure you're doing very well. I don't write checks anymore. I haven't written a check in a long time. Do it all online. Also allows me to check my account for fraud every day I look at it. Sometimes several times a day. E-commerce, there's also stuff you can get this way. We'll talk more about that later. Here he is, Captain Kirk, in his latest persona here. But he's the Priceline spokesperson. And he may seem like a fool on the commercials and the stuff he does these days, but the truth is he became a partner of Priceline years ago when they were starting out. They had very little money, couldn't get the celebrities and advertising. Well, he agreed to do all their advertising for free, but he took a share of the company. It was, I guess, I don't know how much of a risk you would call that. All he was spending was time and maybe his image a little bit, but he still does their marketing, He didn't do it forever. For a while he didn't do it, but now he's doing it again. And the truth is, every time he increases their sales, he gets more money in his pocket. They don't pay him anything. They may pay him expenses, I don't know. But the deal was he got a share of the company. He got equity in the company. And now he's pushing it. I actually used Priceline for the first time the other day, and it worked pretty well. I couldn't find what I was looking for on Expedia, which is Microsoft's travel website. So I went here, and it worked. We'll talk more about this when we talk about the internet. But a shopping bot is a program that actually goes to all the shopping sites and tells you what the price of what you're looking for is on each of those sites. It's a great thing. I mean, this is what one of the things the internet's all about, information. And it's changed the game because the consumer can comparative shop without getting in their car. So you can do that before you leave the house and be equipped to handle what's going on. I haven't had a chance to look at this video. Look at it if you let me know. Hardware. Well, Enterprise has hardware that does all this. You can imagine what you need is a lot of database storage, but you don't have it on one system. Redundant systems. I'm not going to go into this too much. For instance, when I did a system for the Navajo Police Department, they wanted two systems that were identical with a box in between them. Then anything that happened to this system was also sent over to this system. It's called reflection or mirror. It's called mirror generally. The software Hewlett-Packard had at the time was reflection. And the two databases were kept in sync. The two computers were identical. So if this computer died, all they had to do, the system automatically switched to this computer, which was up to date. Then you'd fix this computer, bring it back online, and they would communicate and get each other caught up. So eventually, it would take some time if it had been down a while. Eventually, they'd be both back in sync again. And that's the idea. So that's the redundancy. You need to do that kind of stuff. And making all that information available to all those people in all those locations requires a lot of planning. The hardware helps a lot. Redundant array of independent disks. I just want to say this, that they allow you to store data in different ways. We use it on our server that keeps track of these recordings. As we've talked about, everything is zeros and ones. Well, one of the RAID systems allows you to store an extra bit. So you've got 8 bits in a byte, as we've talked about. You add another bit to that, and you can actually figure out, if you drop one of those bits, what that bit was. By figuring out, if you add all those up, the zeros and ones, they should be either a 0 or a 1 at the end. Well, if you lose one, you can then figure out with a formula that that should be a 0 or a 1. So what our RAID allows us to do is we store each of the bits of those 9 bits on a different disk drive. So if we lose one disk drive, the software we can replace that disk drive, and the software will automatically regenerate that disk drive from nothing. We don't even need a backup. The existing database is a backup. That's the kind of thing RAID can do. If that didn't make sense, don't worry about it. Storage, this is another thing. You need a lot of storage. And again, this is a little more technical than we need to be here. But network attached storage is the way that you can put another disk on a system and it's usable instantly. SAN, same kind of thing. I'm not going to go into that. And there's servers that take care of all the storage. A little too technical for us. Real quick, a blade server is a server that allows you to remove a system or add a system whenever you want to, and the system is smart enough, the overall enterprise system, to use whatever resources you give it. A lot of people are using this concept. Instead of throwing away old, obsolete computers, you can plug it into a blade setup, and although it may not be much processing or much RAM, whatever it is can be used by the system. So it's kind of like all those little parts are automatically used by the system. So you have this rack, you plug another motherboard into it, think about it in those terms. The blade server will automatically go, oh, I have another processor, I have more RAM, I'll just start using that now. You don't have to tell it, you don't have to do anything. It's quite remarkable. It's a way to use old equipment. But this one probably isn't using old equipment, but it's using replaceable ones. You can see they can pull these out, replace them, whatever they need to do. I've already talked about this, high availability, redundant systems. Scalability is the term for designing systems that allow you down the road to make them bigger as you need to without redesigning the whole system. So it's a skill you have in systems analysis. When you design systems, you make them so they're scalable because you don't know what the future is going to bring. Interoperability means be sure that your system is open enough, and that's one of the reasons people are pushing this open source kind of thing, this virtual system, which is going on in the marketplace. Allow systems to talk to each other. They never used to do that. That's the idea. We've talked about backups, but real quick, a full backup takes everything you have and just puts it on another place. So if your computer blows up, you've got everything you had. It takes a long time, but it's the most secure. Differential means just take what changed since the last full backup and back that up. Okay? So you don't do a full backup all the time. You might do a full backup once a week. The other 6 days you do a differential. You need to fix your system. You start with a full backup and then you restore all the 6 differentials. And now you're back where you were a week ago. It means each of the daily backups is smaller, quicker, less resources. That's the idea. Incremental just means just do the things that have changed in the data. Selective means only back up certain things, and that's what I do on the Breeze server. We just back up the Adobe Connect, I should say. We just back up that database. Continuous means anything that happens to your disk is automatically put somewhere else. Okay. I think we talked about this, but real briefly, in order to have a disaster recovery plan, and remarkably enough, a lot of the people in the World Trade Center didn't have these. A lot of businesses just went out of business because they didn't have their data anywhere else. But anyhow, you have to have an emergency plan, which includes who is responsible for what data, where it should be when we get done with the recovery, but where do I get it to back it up, all those things. Where do I get hardware? What building will we be in if this one blows up? And then a backup to make sure you know where the backup is, and it should be off-site in some sense. What most people do now is have a partner somewhere that backs up their stuff on your computer. You back up stuff on their computer, and you're far enough apart. Could be states, could be countries, that if you blow up, they don't, probably. And then a way to get back. Then, of course, you have the testing. And the plan has to include who calls who to find out what data needs to go in what order. What's the priority? And imagine if you lose your accounts receivable, you can't bill your customers. They don't have to pay you anymore. So this is very important. If you lose your accounts payable, you don't know who you owe money to. When you get something in the mail, should you pay it? Should you not pay it? So and you also lose your customer database. Who is a good customer? Who is used to getting good service? All those things are pretty much gone if you don't do a good backup disaster plan, and the goodwill of your company and your reputation is going to be hurt. So that's all. I know it's more than you ever wanted to know about enterprise computing, but again, seeing as how this is a graduate level technology class, I wanted you to get a feel for it. And this is what's going on in the marketplace. This is what's going on in organizations. All the little things we've talked about, zeros and ones and all that stuff leads up to this. This is the ultimate of what we're talking about in terms of big business, in terms of what's going on out there. And I hope it explains some of the practices you're seeing businesses when you call them, some of the things that happens when you go on Amazon, some of the things that happens at your place perhaps. All those things go into this. We've talked about, I guess, all of these things, and I'm not going to go into them again. A lot of this we're going to talk about the e-commerce, especially when we talk about the internet and World Wide Web, which is 2 lectures from now. The next lecture is going to be about how we communicate via the web. via networks, I should say. And we're going to cover that next. So I think I'm done. Thanks for listening. There won't be any assignment right now on this. Check the portal for assignments. Thank you.